Good morning, grade 7. Hope you are all doing well and being safe. This is Ms. Pamela giving the physics course. This is the general revision part 1. First of all, we are going to define energy. Energy is the ability to do work or cause a change. Recall that work is done when a force moves an object through a distance. So we already studied work in the previous chapter, and we stated that work is when force moves an object through a distance. The object must move some distance in the same direction as the applied force. Energy is measured in joules. It is the same unit as the unit of work. For example, wind can move a leaf on the ground, thus it has energy. You can move your book from the desk to your back, thus you have energy. The relationship between energy and work. You can think of work as the transfer of energy, because when an object or living thing does work on another object, some of its energy is transferred to that object. And this is the relationship between energy and work, that work is the transfer of energy. The relationship between energy and power. Power is the rate at which energy is transferred, or the amount of energy transferred in a unit of time. So it is the amount of energy that is transferred from one object to another in a unit of time. This is power. Now, in order to calculate, we have two basic kinds of energy. The first one is kinetic energy, which is the energy an object has due to its motion. A moving object, such as the wind, can do work when it strikes another object and moves it some distance. Because the moving object does work, then it has energy, which is kinetic energy because it is moving. So any object that is moving has energy that is called kinetic energy. Factors affecting kinetic energy. There are two factors that affect kinetic energy. The first one is mass. As mass increases, kinetic energy increases as well, so they are directly proportional. The second factor is velocity. As velocity increases, kinetic energy increases as well, so they are also directly proportional. Calculating kinetic energy. To calculate kinetic energy, we use the equation shown in front of you. Kinetic energy is equal to mass times velocity squared over 2. Kinetic energy is measured in joules, mass is measured in kilograms, and velocity is measured in meters per second. The second kind of basic energy is called potential energy. It is the stored energy that results from the position or shape of an object. This type of energy has the potential to do work. This is why it's called potential energy. An object does not have to be moving to have energy, which is kinetic energy. For example, when you lift a book up to your desk, you transfer energy to it that is stored and can be used later. This energy that is not related to motion is called potential energy. There are two kinds of potential energy. The first one is called elastic potential energy. It is the potential energy associated with objects that can be stretched or compressed. For example, when an archer pulls back an arrow, the bow changes shape. The bow now has elastic potential energy because it is the energy that an object has due to its stretching or compression. The second kind of potential energy is called gravitational potential energy. It is the potential energy related to an object's height. For example, when you sit at the top of a slide, like in the figure you see in front of you, you have gravitational potential energy due to your height above the ground. In order to calculate gravitational potential energy, we use the equation shown in front of you. Gravitational potential energy is equal to weight times height. Energy is measured in joules, weight is measured in newtons, and height is measured in meters. Now we are going to talk about mechanical energy. Mechanical energy is the form of energy associated with the position and motion of an object. Examples: a moving car, a trophy on the shelf, a ball thrown in the air, etc. So, the kind of energy that is associated with both position and motion of an object is called mechanical energy. So it is like a combination of kinetic energy and potential energy. Now we are going to talk about how to calculate mechanical energy. Since mechanical energy is associated with both the position and the motion of an object, so an object's mechanical energy is a combination of its potential and kinetic energy. You can find an object's mechanical energy by adding its kinetic energy and potential energy. As you can see in the equation in front of you, mechanical energy is equal to potential energy plus kinetic energy. And of course, the unit of energy is joules. Other forms of energy. An object can have other forms of kinetic and potential energy not associated to the motion or position of an object. So an object can have energy other than mechanical energy, which is associated with the position and the motion of an object. Most of these other forms are associated with the particles that make up the object. There are 5 other forms of energy. 1. Thermal energy. 2. Electrical energy. 3. Chemical energy. 4. Nuclear energy. And 5. Electromagnetic energy. Energy transformations. Most forms of energy can be transformed into other forms. Energy transformation is the change from one form of energy to another. Some energy changes involve single transformations, while others involve many transformations. So energy transformation is when one form of energy changes into another. We can have single transformations and we can have many transformations. There are single and multiple transformations. In single energy transformations, one form of energy changes into another form in order to do work. However, in multiple energy transformations, a series of energy transformations occur in order to do work. So in single energy transformations, only one transformation occurs. In multiple energy transformations, a series of energy transformations occur in order to do work. Conservation of energy. The law of conservation of energy states that energy cannot be created nor destroyed. It only transforms from one form to another. So, the total amount of energy is the same before and after any transformation, like the one you see in the image in front of you. The total amount of energy remains 50,000 joules, but the kinds of energy transform from one kind to another. Energy and friction. There is a relationship between energy and friction, and we are going to talk about it now. Whenever a moving object experiences friction, some of its kinetic energy is transformed into thermal energy. So you might think that this kinetic energy is lost, but no, it is transformed into thermal energy whenever an object experiences friction. For example, and it is a simple example, when you rub your cold hands together to warm them up, you are transforming the kinetic energy, because the hands are moving, into thermal energy using the friction between the hands, because the surfaces of your hands are rubbing against each other. So we have friction, and since they are moving, we have kinetic energy. Because of friction, because your hands are experiencing friction, this kinetic energy is transformed into thermal energy. This explains why no machine is 100% efficient, because we always have a transformation between kinetic energy and thermal energy because of friction. What are fossil fuels? A fuel is a material that contains stored potential energy. Fossil fuels are fuels made from material that formed hundreds of millions of years ago. For example, coal, petroleum, and natural gas. So in a general definition, a fuel is a material that contains stored potential energy. However, fossil fuels are specific kinds of fuels that are made from material that formed hundreds of millions of years ago. But how is that even possible? How can we use materials today that are made from materials formed hundreds of millions of years ago? So how do fossil fuels form? When plants and animals in ancient forests died back in time, their remains piled up in thick layers. Where did they pile up? In swamps and marshes. Then clay and sand sediments covered these remains, and the resulting pressure and high temperature turned the remains into fossil fuels. So fossil fuels that we use today are made from the remains of plants and animals that died in ancient forests hundreds of millions of years ago. Now I'm going to talk about energy transformations in the formation and the use of fossil fuels. This is very important and it contains several steps. So please concentrate with me. The first step is in the sun. So as we already stated, the fossil fuels contain energy that comes from the sun. The sun transforms nuclear energy to electromagnetic energy. So nuclear reactions in the sun transform the nuclear energy into light energy, which is also called electromagnetic energy because light waves are electromagnetic waves. Then, in the second step, ancient plants and animals transform this electromagnetic energy from the sun to stored chemical energy, and their remains become coal. As we already explained, when these ancient plants and animals died, their remains were covered by layers and layers of sand, silt, and water, and because of the high pressure and temperature, they turned into fossil fuels. In this example, we are talking more specifically about coal. In the third step, coal is burned to make steam. This transforms chemical energy to thermal energy. So in these three steps, we have three energy transformations. The first is from nuclear to electromagnetic in the sun. The second is in ancient plants and animals. The transformation is from electromagnetic, which is light energy, into chemical energy. And the third is when coal is burned. It transforms the chemical energy that is stored in the ancient plants and animals into thermal energy, which is heat. In the fourth step, steam turns turbines, transforming thermal energy to mechanical energy. So as we already stated in the third step, when coal is burned, chemical energy is transformed into thermal energy. This thermal energy is transformed into mechanical energy when the steam turns turbines, which are like big fans. In the fifth step, these turbines spin electric generators, and thus it transforms this mechanical energy into electrical energy. And in the final step, we use this electrical energy in the devices at our homes or schools or whatever. So here they are giving a specific example, the hair dryer. The hair dryer transforms electrical energy to thermal energy, which is heat. So we have six energy transformations. The first is in the sun, from nuclear energy to electromagnetic energy. The second is the transformation by ancient plants and animals from electromagnetic energy into stored chemical energy. The third is when we burn the coal or the fossil fuel, we change the stored chemical energy into thermal energy. Then this thermal energy is used to produce mechanical energy in turbines, and these turbines are used to transform mechanical energy to electrical energy when they spin electric generators. And finally, the final transformation is by us at our homes or schools. It depends on how we use the electricity or the electrical energy that reaches us. So we may use it by a hair dryer, we may use it by a toaster, by a washing machine, by a lamp. So the energy transformation depends on the device that we use. Note, fossil fuels can be burned to release the chemical energy stored millions of years ago, and this process is called combustion. So whenever we burn fossil fuels in order to release the energy stored inside of them millions of years ago, the process is called combustion.